So we are still going to use elimination, but whenever we look at number 17, our goal is to try to multiply one of the equations so that you get the same number, except for one's positive, one's negative, and then that variable is eliminated. But is there anything I can multiply 4 by that will give me 7? Not a whole number, right? What about 7 times something will give me 4? Nope. What about 8 times something that gives me 9? Anything I can multiply 9 by that will give me 8? No, nothing with a whole number here, right? So, whenever we have problems like this, what we're going to have to do is we're going to have to multiply both equations. And so the easiest thing to do is just multiply by the opposite number. Except for in this case, we want to choose which one we want to get rid of, either the x's or the y's. I think I'll choose x's here just because the numbers are a little smaller to deal with if I do x's. So I'm going to multiply this top equation by 4 and the bottom one by 7, and I think I'll make that bottom one negative 7. You can make either one of them negative. It doesn't matter if you do top or bottom. So when you do this, you have to multiply every number in the equation. So we'll get negative 28x minus 32y equals 36. And on the bottom, we'll get positive 28x minus 63y equals, let's see, 22 times 7, 14, 31, 14, 15, 154. So we get 154 here. Okay, yep, so now our x's are going to eliminate. We're going to add everything else together. So if we do negative 32 and negative 63, we're going to get negative 95y. And then over here, 190. And if we divide both sides by negative 95, what are we going to get for our y? Not 3. It's going to be negative 2. Okay, questions here? All right, what do I do to find the x-coordinate? Because I need the x-coordinate as well. Plug in. Which equation do you guys want to use, top or bottom? Okay, we use top. Negative 7x minus 8 times negative 2. We actually should get a positive 16. Just because you're doing negative times negative there. Yeah. And we're going to get negative 7x equals negative 7. So if we divide both sides by negative 7, x equals 1. So we get the point 1, negative 2. We did not put systems on the exam. Yeah, since we haven't had a chance to quiz on this yet. We will, after Christmas, we will continue more with this and review, and we got to do some word problems and stuff with it and take a test on it. So it's not going away, but it won't be on the exam Friday. Okay? All right, let me, I'm going to open up the Smart Notebook so I can write a little bit bigger for my visually challenged. It seems to be more and more kids. All right. save these real quick. All right. Let's look at number 18 now. So for 18, you're running into the same problem. You can't multiply 3 by anything, they'll give you 5. You can't multiply 4 by anything, they'll give you 9. So to eliminate, you're going to have to multiply both top and bottom equations. So you can get rid of the x's or the y's. It does not matter. Just to show you that it doesn't matter and you could do either one, I'm going to deal with the y's this time. So I'm going to multiply this top equation by 9 and the bottom equation by 4. And I don't have to change any signs here because I already have opposite signs for my y.
Does it matter where you put the 9 and the 4?
Yes. So I've got to do, since the 9 is with my y in the bottom equation, I have to multiply the top equation by it.
Okay.
And then since my 4 is in this top equation, I have to multiply the bottom one by it. And so what happens is you're doing 9 times 4 here, and you're doing 4 times 9 here, and those both are going to give you the same value.
Okay.
So when we distribute here, we're going to get 45x plus 36y equals negative 270. And then we will get 12x minus 36y equals, let's see, 18 times 4, negative 72. Okay? All right, so at this point, y's will cancel out. And so over here, we're going to get 57x. And over here, we're going to get negative 342. And most of what we're going to do with this is going to be calculator inactive. However, this worksheet and possibly Delta Math may sometimes give you some numbers that are a little bit large. So if you grab your calculator for that, it's okay. I think we should get negative 6. That's what Marley tells me. That seems reasonable. All right, questions? All right, we need the y to go with it because whenever we're solving a system of equations, we need the x and the y coordinate. Once we find this, Zane, what do we have to do with that x? When we find x equals negative 6, what do we have to do to find the y coordinate? Okay, Julian, tell them what to do. Doesn't matter, whichever one you want to use. Good. And then we'll have plus 4y equals negative 30. So this is going to be negative 30 plus 4y equals negative 30. I'll have to add 30 to both sides, which is actually going to cancel on both sides. So 4y is equal to what? 0. I'm going to divide by 4. And so y equals 0. So my coordinates are negative 6, 0. Yeah, you don't have, you could put it in the bottom one instead if you want. It's going to give you the same answer, but you don't have to do anything else with it. So you just pick whichever one looks easier to you and use that. All right, questions on number 18? All right, let's skip over to number 22. All right, so there's no number I can multiply 2 by that'll give me 5. There's no number I can multiply 8 by that'll give me 20. So I'm going to have to multiply both equations here. So, Peyton, which one would you rather get rid of, the x's or the y's? Okay, so if we do that, we are going to have to multiply the top equation by 20 and the bottom equation by 8. So we will get 40x plus 160y equals 120. And we will get negative 40x minus 160y equals, so we negative 120. Yeah. Ooh. All right, so our answer is not 0. Now on the left side, everything's going to cancel out. We will have a 0. On the right side, everything's going to cancel out. We will have a 0. Okay, so 0 does equal 0, correct? So what is happening here, it's not no solution. It would be no solution if we got something like 0 equals 50. It is, we're going to call it infinitely many solutions. So if you do this and both your x and your y's cancel out, then it's either going to be infinitely many solutions or it's going to be no solution if you get something like 0 equals 7. Okay, questions? All right, we're going to do one more from here. All right, for 24. 24 is a strange problem because it doesn't look like the ones we've seen before, right? But we can manipulate 24 to put it in the same form as what we've been dealing with before. Right, so what we need is we need our x's to line up. Sorry. Our y's to line up, our equal signs to line up, and then we need to have a number here on the other side. So for that to happen, we need to take this 3, we need to move it to the other side. So that will give me 2x minus y equals negative 3 for that top equation. When we move something to the other side, you got to change its sign. We'll need to do that same thing here. We'll need to move that negative 3 over. We got to take the 10 and put it over here. So we're going to have negative 10x minus 7y is going to equal positive 3. So you have to get everything lined up first before you can use elimination. We could multiply this top equation by 5. Or you could multiply that top equation by a -7 if you want to cancel the y's, but let's do 5 like you said. So we will get 10x minus 5y equals -15. And then we'll get -10x minus 7y equals 3. So this is one where, kind of like you were doing yesterday, where you can just multiply one equation. I chose 5 because 2 times 5 would give me 10, which would cancel with that -10x in the bottom. However, you could have chosen to multiply based on that y over there. You could do like a multiply by a -7. That'll give you a +7 here and a -7 here, and the y's would cancel. You'll end up with the same answer in the end, no matter which one you choose. Okay? So, I'm going to cancel that out. We'll get -12y equals -12. So if you divide both sides by -12, you get 1. Then, for our x, we're going to plug back into one of the original equations. We could go all the way back to the very original equation, or we could use this. It really doesn't matter. Let's go all the way back here. I think I'll use the bottom one. -3 minus 7y equals 10. Oh, wait. I'm plugging in for y, not x. So my y right there needs to be a 1. So we got 7 times 1, and then we got 10x. So that's -3 minus 7, which gives me -10, equals 10x. I can divide both sides by 10. So -1 is my x. So my answer would be -1, 1. Okay, questions? Yes. I just used the beginning equation here. So I went back and used this equation. If you used this instead, that's okay too. Either one is fine. Okay, questions? All right. So your assignment today is on Delta Math. So I need to change the date because yes. Some of these will be the simple ones you did yesterday. Some of them will be the more difficult ones. So go ahead and get started on that.